Hi guys, today we're going to be talking about the second day of the Pythagorean theorem. So let's just recall that, remember, a Pythagorean theorem is about any right triangle, and there's two different pieces to this. There are the legs, which are on either side of that 90-degree angle. So those are my a squared and the b squared. And then the longest side of my right triangle, that's always opposite that 90-degree angle, that's my c squared, which is also known as the hypotenuse. So A and B, every single time in your Pythagorean theorem in your right triangle, these are called the legs. And side C, your longest side of the right triangle, is called the hypotenuse. And just as a reminder, the Pythagorean theorem is always used to help us find a missing side length. So we're always looking for a missing measure of that right triangle. So in lesson 1 of the Pythagorean theorem, we were given A and B, and we were trying to find C. Today, we are given the hypotenuse side, and we're going to try and find the missing leg. So just as a quick reminder, I'm going to throw up that Pythagorean theorem formula, which is a squared plus b squared equals c squared. And we're going to use that today to fill in the information, kind of like we did on day 1. But today, we only have one of the sides. So I'm going to label that side my a. And we know that 12 is our hypotenuse, or side C, because it's opposite that 90-degree angle. And this time, we don't know what B is, so we're going to leave B as a question mark, or just as the letter B. So let's start by plugging in some information. We have A squared, which we labeled as side 3, plus B squared, which I'm going to leave as the letter B, because I don't know it, equals C squared, and this time we know that C we labeled as the number 12. So new information this time, we're missing side B. Okay, let's start by doing what math we can do by squaring. So 3 squared is 9, plus B squared is just going to stay B squared, but we can drop those parentheses, equals 12 squared, which is 144. Okay. Our goal in this type of problem is to get the b squared by itself. So your next step for all of these today is going to be subtracting whatever number is with that b squared so that it can go by itself. When I subtract, 9 minus 9 cancels out, and I'm left with b squared on that side, equals, and then I have to subtract 144 minus 9, and that gives me 135. Our last step here is to take the square root of both sides to get rid of that radical, which means I'm just left with the letter B, kind of how in lesson number 1 of the Pythagorean theorem we were just left with the letter C. But remember, just like in lesson 1, we have to break this down if we can. So 135, that can be broken down into 5 and 27. And 27 can be broken down into 3 and 9. And again, I like to get rid of them as I go. And then 9 can break down into 3 and 3. And I'll get rid of that 9. So I see a pair of 3's. So that means a 3 goes on the outside of my radical. And the 3 and the 5 are left alone. Remember, any two numbers that are alone together, they multiply back together to go inside. So my answer is 3 radical 15. And just like we did in lesson 1, we can't forget our units, so centimeters. And that's my answer for side B, 3 radical 15 centimeters. Okay, let's try another example together. Example number 2. Same idea here. Let's just jot down that Pythagorean theorem so that I have it on the side of my paper. So it's a squared plus b squared equals c squared. And let's start by labeling what information I do know. So on the legs, I have 4. 4 is my A, and I don't know my B, but I do know that side C is opposite that 90-degree angle, and it's always going to be my diagonal side, my longest side, which in this case is 9. So let's plug in our information. We were told that a squared is 4 squared, plus b squared is going to be kept as the letter b, equals c squared, which in this case is the number 9. Okay, our second step is to do what math we can. So 4 squared is 16, plus we can drop those parentheses, b squared equals 9 squared, which is just 81. Okay, third step, just like in the first example, get that b squared by itself. So subtract 16 on both sides, and I'm left with b squared equals 65. And as our last step here, I want to take the square root of both sides, because that will undo my squared and my radical. So now I have just the letter b by itself equals, and we want to break down that 65. 65 can be broken down by 5 times 13, but unfortunately we can't break that down any further. 5 can't be broken down and 13 can't be broken down. So remember that if it cannot be broken down, that means radical 65 is the simplest form of that radical, and that would be my answer. But our units are feet, so we're going to put feet on my label. So side B in this case is radical 65 feet. Okay, I'm going to do a third example with you guys just to make sure we really got the hang of it. So example number 3 is same idea. We want to start by writing down our Pythagorean theorem. So our Pythagorean theorem is a squared plus b squared equals c squared. And then we'll label our sides. So we know that one of the legs is 9. I'll give that an A. And the other leg we don't know, so we're going to label it with B. And we do know that across from our 90-degree angle is our diagonal, or our longest side, and that's always the letter C. So now let's plug in some information. We have a squared, which is just 9 squared, plus b squared, which I don't know, equals c squared, which we said is 15. 9 squared is just 81, plus b squared, we can drop those parentheses, equals 15 squared, which is 225. Okay. Third step, we want to get that b by itself, so I'm going to subtract 81 on both sides of my equation, and I get b squared equals 144. And then my last step, I want to take the square root of both sides because that undoes my square and my square root. So that gives me the b by itself equals, but be smart here. Some of you might think, I'm going to break down 144, which you absolutely could do. But 144, we know, is actually, yep, I'm going to draw my heart here, it's a perfect square, right? 144 is really just the square root of 144, 12. So you could absolutely break that down or just be smart about it. Since 144 is a perfect square, 12 is my answer. And again, just like we did in the last bunch of examples, our units are meters. Okay, so that's the gist of it for today, guys. You are going to work on problems 4 through 10. I want to see all of the steps shown, just as we did in those first 3 examples. And if you have any questions, stop into office hours. Thanks, guys. Have a good day.